All right, guys, welcome back to Quarantined Algebra 2. Hope you all had a good spring break. So it is Tuesday, April 14th, and we are going to keep on moving with our packet here. So this is where we left off. At the end of last week, we were talking about adding and subtracting rational expressions with unlike denominators. Now that's still where we're at, but instead of just some unlike denominators that are a single term, 8x or 2x squared, something like that, we have some denominators that are entire binomials or even polynomials in some cases. So we are going to work on numbers 9 and 10 today. We are going to see how to address stuff like that. And the big thing here is that whenever we take a look at these different denominators, we need to factor them out as much as possible. And I know you guys have had tons of experience with factoring out recently, because that's literally what we've been doing ever since we went on quarantine. Is almost every term we see, we try to factor. So the interesting thing here, the unique thing here at least, is that we're only really factoring initially in the denominator. We can ignore really the numerator and everything it's doing for the time being. We don't got to worry about the numerator at all. We'll worry about that after we go ahead and subtract these. But we're going to factor this denominator down right from the start. And you'll see why we want to do that as we get to working on this. So right now we have 5k minus 10 and k minus 2. So you start thinking, well, goodness, I got to change k into 5 and 2 into 10. How do I change these? Do I do it separately? What happens? Well, we may not have to ask those questions, or at least not have as difficult of questions to ask if we factor these. So when I look at the denominator, 5k minus 10, I notice that can be simplified. I can factor it out. Both of these numbers are divisible by 5. So if I take out 5, then I'm left with k minus 2, because I'm just dividing 5 with both of these. Now this side just has k minus 2, right? So now that I look at this, I realize that it's not necessarily that I'm missing some individual numbers in both of these terms. They both have a k minus 2. It's just that this side doesn't have a 5. That's how this works a lot of times whenever we have binomials or polynomials in the denominators. We want to look and see, okay, what does this side have that the other side doesn't? And then we try to add that into the other side. So since we're noticing this side has that 5 in the denominator, this side doesn't, then we want to go ahead and multiply this side by that 5 to get it in there. Now 5 times k minus 2, well, that's just going to put that 5 out there, and I'm going to leave it in factored form. And then my numerator, this one stays the same because I'm not multiplying that side of the equation at all. But this one is 4 times 5, so that's going to be 20. Now I can go ahead and subtract these. Remember, when you're adding or subtracting rational expressions or any fractions, the denominator stays the same. So we end up with k squared plus 16 minus 20 over 5 times k minus 2. Okay, so now I have a little bit of simplifying that can happen. You'll notice in the numerator we have two whole numbers, k squared plus 16 minus 20. Well, let's combine those. That's going to give us k squared minus 4 over 5 times k minus 2. Now that we have this combined, we want to ask ourselves, can we factor the numerator? We already factored the denominator. That happened in the beginning. But we have a numerator now that maybe can be factored. Well, can we factor it out? Do they have anything in common? No, they don't. Can we box method it? Is it a full polynomial? No, because it only has 2 terms. But is it a difference of squares? Well, we are subtracting. On one side we have k squared, the other side we have 4. Both of those are perfect squares, so it is. Now, the difference of squares says we're going to break this down into 2 binomials. one that is adding, one that is subtracting, with the square root of each of these. So the square root of k squared is k. Like we said, one's adding, one's subtracting, and the square root of 4 is 2. So k plus 2 and k minus 2, still over 5 times k minus 2. This gets us down to our classic case where we can cancel some stuff out. We have some redundant binomials, k minus 2 in the numerator, k minus 2 in the denominator, and we're left with just k plus 2 over 5. All right, so we're also going to try out number 10. I know this seems like a little bit longer of a process than we were working on, but it's not that much more complex than everything we've been doing for the last few weeks. So let's go ahead and look at number 10 here. So we have y minus 8 in one denominator. Well, that's not changing. That's already in simplified form. But we have a polynomial in the other one, so we want to box method that. Now, if you go ahead and box method that, if you're unsure how to box method, there's a video on the Google Classroom from very early in the month or late March, specifically over box methoding. You'll see it labeled there. But we end up getting y, let's see, 24 factors of it would be 12 and 2. That's not going to work for 11, 8 and 3. Y plus 8, y plus 3. So you'll notice this denominator is y plus 8. This denominator is y plus 8 and y plus 3. So what we have here is a y plus 3 that we don't have here. Again, like I said in the last problem, usually what you want to do is you want to take a look and you just want to ask yourself, what does this denominator have that that one is missing? And you may have to ask that about both denominators, but in this case it's just one. So we need a y plus 3 on this side. Well, we can multiply that in. Luckily, we can multiply in binomials the same way we multiply in whole numbers. Just like we multiplied in the 5 in the last problem, we can multiply in y plus 3. So we're going to have y plus 3 times 7. Well, that 7 is going to distribute to both of these, making 7y plus 21. And then the denominator will be the y plus 3, y plus 8. This side does not have to change because it already has everything in our denominator. So we have a 35 over the same thing, y plus 3, y plus 8. We want to go ahead and combine our terms, or combine the fractions. 7y plus 21 plus 35. I'm going to just go ahead and combine these right off the bat. 21 and 35 is going to get us, what is that, 56? Yeah. So 7y plus 56 over y plus 3, y plus 8. We want to see that numerator if it has anything in common, if it has a way to factor it. Both of those numbers are divisible by 7, so I can factor that out. If you take 7 out of 7y plus 56, we get y plus 8. And then we have our denominator of y plus 3, y plus 8. We notice here we have some redundancy. We have a y plus 8 in the numerator and denominator. So we are left with merely 7 over y plus 3. And that is our answer. All right. If you guys want to try out number 11, you can. We will go over the answer to number 11, and we'll also do number 12 in tomorrow's video. If you have any questions, feel free to email me. Otherwise, I'll see you then.